Good morning, everyone. My name is Sean van der Walt from Friendly Technologies. I'm the IoT Product Director at Friendly Technologies. So it is now spot on the hour to get this webinar started. I think there may be still some attendees logging in, but without further ado, what we'll do is we'll get started so that we could maximize the 1 hour slot that we have right now. Just a few things. What I'll do is let me go through a agenda, what we're going to cover today. So from a Friendly Technologies point of view, what we've seen in the customer base around the world is a inflection point in the IoT market, and that is around practical applications. And we're seeing this growth in the IoT market around IoT devices and applications and services around this. And this is driving a need to manage these deployed IoT devices around the world. Okay, so I guess if you're having issues hearing me, I think you're all on mute, and you can drop a chat or two in the chat message. If you cannot hear me clearly, then just let me know if there is an issue. So just during the webinar session, if you have any questions, there should be a questions chat box. So just pop those questions in the question chat box as we're going along. And then when we get to the end of this webinar session, I will get around to answering. I'm not sure I'll be able to answer all the questions in the time allocated, but we'll certainly try. And if not, we will be getting back to you with responses on the questions posed during the session. So today we're going to cover a couple of topics. One is the major benefits of IoT device management. And what does that really mean for you as a user, consumer, customer, service provider? We're going to cover some topics around the interoperability testing for IoT devices. I think that's quite important in terms of devices being able to interop with different platforms and different platforms interoperating with different devices. So we'll cover some of that. I'm going to be talking about the interconnects to the IoT application enablement and IoT cloud platforms. So we'll cover that in a few slides as well. And then I'll be going through what we as Friendly have to offer in terms of our carrier grade One-IoT device management platform and how that addresses these points and how some of our customers are actually utilizing our platform in an IoT context. Okay. So without further ado, just give you a quick snapshot of Friendly Technologies. I'm not going to be too heavy on the marketing side. It's going to be more technically orientated today, but yeah, this is kind of just paying the rent. So what is Friendly? Friendly at a glance. So we're a software solutions company. We're a product company. We develop software. We don't do any hardware. We use partner vendor products in the hardware space. So, and as I said, it's all about that interoperability. So, product, software, that's what we do. And the second point shows that we're focused on device management. So that's really the key message. From a Friendly Technologies point of view, we're not a be-all and end-all for everything. We're very much focused around the device management component. And just, yeah, we've been serving this market since 1997. We mainly deal with carriers and XSPs because that's historically the customer base, mainly because of the broadband device management. You know, if we're talking about broadband devices itself and service providers using those and wanting to manage broadband devices. So that's our history for, you know, close on 22 years now. And since 2006, we've kind of standardized a set of products covering that device management component. So just in terms of the market space, the lightweight M2M as a standard was ratified around February 2017, so more than 2.5 years ago. And just prior to that, we developed our first lightweight M2M device management platform prior to the ratification of version 1.0 of the lightweight M2M standard. And why I'm mentioning this is because it really touches one of the points around our customer base being carriers and service providers. We today have enterprise customers now utilizing our One-IoT platform for IoT device management, and from a company point of view, we'll see a proliferation of customers using device management to manage IoT devices, and not just a select target audience of service providers. But yeah, we will see those enterprise customers being customers like utilities and various other customers who want to manage their own fleet of devices would be able to do so. So we see ourselves as the most installed unified device management solution. So unified device management is a key part of what we offer. Unified being we can manage all device protocols out of one platform, including custom protocols, and I'll get to that later on. So we have a strong global network of channels, distributors, and system integrators. We essentially work in all global markets, and yeah, we're a member of the Broadband Forum and the Open Mobile Alliance, which are the organizations driving, for example, the TR069, TR369 standards, and OMA being the ones around OMA-DM and lightweight M2M. So we're an active participant in those forums and attend test fests to test our platform against other devices and clients and so forth. So we have our headquarters in Israel. We are an Israeli company, but we do have offices in the US, in Colombia, Ukraine, and China. And just a point is our Ukraine office, we have quite a number of R&D staff based in our Ukraine office, and our R&D staff in our Israel office as well. Then in terms of the customer base, we historically have over 250 carrier and XSP customers, but as I said, that's going to kind of boom now, mainly because of the types of customers wanting to use IoT device management. So we're seeing that proliferation in the process at this present point in time. We have a couple of significant sizable customers with some up to 100 million devices. We have recently signed our One-IoT Device Management platform to a Fortune 500 company that have plans to connect over 1 billion IoT devices using narrowband IoT as the carrier, but or the access network. But yeah, so this is pretty significant in terms of where things are going in this IoT space. Okay, so enough about the company background. So just giving you a couple of slides on what is this IoT device management? How does that fit into the IoT framework or the IoT space? So this little picture is a very, very simplified version of that. So it's really the IoT puzzle, and the IoT puzzle consists of many, many puzzle pieces. Hopefully not too many, but certainly there are. You will find some companies who try and offer everything out of one platform. So we find often that they might have touch and have some of the components of many of the IoT pieces of the puzzle, but they're not good at any one particular thing, or they might be good at one particular area, like application enablement, like being able to develop IoT applications in dashboards. So they might have come from that background, but they may not be strong in things like connectivity enablement or device management and so forth. So from a friendly point of view, as I said, we focus on that device management piece of the puzzle. But when we look at that the puzzle landscape in the IoT space, of course, there are other components that form part of an IoT solution. So one of the important ones are the connectivity enablement. So now being able to provision SIMs and embedded SIMs. Today, IoT devices are using the embedded SIM technology, and there's a host of complications around managing those SIM profiles and re-provisioning those SIM profiles for IoT devices to use. But so there are specialist companies working in that space. From a device management point of view, certainly there's a touch point there in terms of being able to activate, deactivate, look at usage on SIM devices and so forth. So that's potentially a touch point between device management connectivity enablement. Then another area is what we call analytics, but analytics and machine learning and artificial intelligence is very, very big area. So, but within this IoT platform space, some companies do offer analytics internally in their system, but we are seeing more trend around using the best breed for each of the pieces of that puzzle. So the best of breed for device management, the best of breed for connectivity enablement, and similarly the big cloud vendors like Amazon and Microsoft and Google and quite a few others offer analytics solutions from within their cloud environment. And what we do is we facilitate the transport of IoT-based data information from the edge device through to an analytics platform, and I'll go through that a little bit later on. And another is what we call the application enablement, or app dev. So the application enablement part, whilst is quite an important area, there are many vendors offering the application enablement solution. And from a device management point of view, again, there's a interface and interaction with an app enablement system, and I'll go through that a little bit later on. Right. Okay, so what are some of the challenges in managing these IoT devices? We're seeing IoT service providers are interested in generating revenue by selling their network and of course, pushing low ARPUs with product or access networks such as Narrowband IoT, Cat-M1, are pushing some of the service providers or operators to start offering over-the-top revenue services, so additional software stacks, additional service applications to be able to gain more revenue from their customer base or that particular vertical application. So and many of these involve a lot of manual processes, so you'd rather try and avoid those manual processes of connecting all these different types of devices in the market with loads of different protocol options, and that really complicates this equation. So challenge number one is being able to connect up multiple types of devices supporting various protocols. So I'll give an example. A very low footprint IoT device may only support a CoAP transport, or it might have an HTTP endpoint. Of course, with the OMA lightweight M2M client, it is kind of positioned for the very low footprint resource constrained devices. So again, just a few different protocols just for high volume resource constrained IoT devices. So that's various protocols, and going into the high end protocols in gateways such as TR069 or TR369, or even IoT applications on like Android or Windows type GUI devices. So they're using protocols such as OMA-DM, which may be a bit old, but yeah, just showing you many different protocols, and this is a headache for service providers. And so all of these different types of devices with different protocols needs to be able to be managed out of one unified platform. So that's challenge number one. Challenge number two is the need to avoid a heavy investment in manual work to make these devices manageable. So we're talking there about loading up a new type of device into the platform where the protocol either may be one of the standard device management protocols, or it may be a non-standard or an unstructured device management protocol, so something like HTTP or CoAP, or it may even be a custom protocol. So then how to avoid the manual effort and intervention required to get that protocol into the platform. So, you need to be able to provision that device. You need to be able to create certain configuration files for the device, or configuration profiles. There is, things like homologation, things like testing that particular device. So that's quite a big challenge for service providers. And challenge number 3, the device must be fully managed as well. So you don't want to have a generic IoT platform that handles, for example, MQTT or a CoAP device, and it's able to collect data from the device, and what often they call device management or data management. It really is data management, so managing the sort of selection of sensor data coming from the device. But those generic IoT platforms forget about the important bits, is the provisioning, the diagnostics and repair, the security part of bootstrap and registration of the devices, ensuring that security channel, doing firmware over the air updates, but not just doing it on individual devices, but selections of groups of devices, and creating campaigns to manage huge fleets of these devices. So that's quite a serious challenge. So what I'll do is, further in as we go through the slides, I'll address some of these points, and you'll then it will become a bit more evident in terms of what we have to offer to cover these points. So, I kept on referring to this kind of a generic IoT platform. So this is just very high level, and yes, it does show up the strong points of a device management platform in a device management world. And again, where the generic IoT platform is not that well suited to the device management specifics that you need. So, of course, things like the provisioning, so being able to pre-provision a device or provision a device, and that could be as simple as a device arriving from the factory with some kind of a default configuration, and you as the operator or service provider want that device to assume a new configuration. You might want to optimize over the air messages, you might want to optimize the power saving modes, so there's various things. So that provisioning and pre-provisioning of the device is very well automated in a device management platform, whereas the generic IoT platforms don't do that well at all, or if they try and do it, they're very weak at doing that. So management of complex of devices with complex data models. So a lot of the device management protocols have a specific type of a data model. TR69, TR369, lightweight M2M, OMA-DM, they all have their own data models. They're fairly complex data models, and generic IoT platform is very weak in being able to interface with those types of protocols. And you'll often find most generic IoT platforms don't have those device management protocols supported in their platform. So, so that's another strong point. Then the different types of managed devices. So, as I said, it could be all the different types of protocols. And, we're talking for device management, unified device management, talking protocols like TR069 being the old one, TR369 USP being the new advanced version of that. We'll touch on those a little bit later on. MQTT, MQTSN, lightweight M2M, CoAP, HTTP, and there's a myriad more, but generally a unified device management platform can handle any of those, including custom protocols. So a device might come in with a complete custom interface to the device, and of course to bring that on board into a device management platform, one does need the interface protocol for a complete custom type of protocol. But once that is known, the device management platform essentially adds an adapter to handle that custom protocol, and that adapter then standardizes the device management interface in terms of the data model as well as the operations to that custom device. And generic IoT platforms are very weak in being able to do that. So things like monitoring the parameters and triggering events, yeah, so both are pretty good at that. Collection of data, yes, an IoT platform is good at that too, but there are exceptions. Many of the generic IoT platforms do not support those management protocols like Lightweight M2M and the new TL369 USP is an example, where there's a scheme and mechanism to bring sensor data in through those management protocols. It's more than a management protocol, but yeah, that's where the device management platform is very strong. Things like group updates, or what we call campaign management, so being able to configure firmware of the updates to devices during specified timeframes, being able to reset devices, push configurations to devices, you name it, lots of different options, and that's where the device management platform shines. Doing things like device diagnostics and repair. So since the device management platform has a strong knowledge of the protocol with the device and the data model of the device, it can perform a lot of more detailed diagnostics and automated repair type options for managing those devices. And then just general application interfacing. So again, the device management fits in as that piece of puzzle and integrates with the different types of IoT platforms. But yeah, the generic IoT platform usually that's its strength, is being able to develop IoT app enablement applications on dashboards or on web type applications. But a device management platform is not about developing IoT web type applications, but facilitating all the data and interfaces to a cloud or IoT app enablement system for the generation of that type of application. So that's the kind of main differences there. So I'll just go through one or two slides on what are typical use cases. We are finding that water utility metering is quite a large use case globally. Just as an example, we had already started a project more than 2.5 years ago for a world first narrowband IoT lightweight M2M based digital water meter project trial with a water utility here based in Australia. However, this process was proven to provide overseas vendors with the tools to develop their digital water meters to support a IoT-based protocol like Lightweight M2M, and this has been proven very successful. So the narrowband IoT type of water meters are required to get something like a 12-year battery life out of the water meter, and to do that, there's some advanced power saving. And with all those EDRX power saving options in narrowband IoT, the Lightweight M2M protocol needs to cater for that, and the device management platform needs to cater for the interaction with those types of devices when they're asleep, being able to queue up commands, when they awake, being able to receive sensor-based data from the device, which is all configured or pre-configured with that water meter. So getting flow rates, getting pressure, temperature readings, and so forth from the water meter, and doing that at scale. We're talking any one utility of many multi-millions of these smart meters, and you can imagine that this has to be bulletproof to reduce any truck rolls or site visits by technical staff to repair or replace or fix things on inside. So it has to be pretty bulletproof. So it's just showing an NB-IoT based RTU, so remote telemetry unit, so something that a bit more powered, a more real-time type of valve monitoring and opening and closing of valves, and monitoring water levels and so forth. So, different types of applications, but yeah, this lightweight M2M protocol is well utilized in this type of application. So another, like a good example, is in the agri-tech, where if we look at automated irrigation as one example, and asset management is another example here, is here's a mixture of access technology. So you may use, for example, a Cat M1, or it could be 4G, 5G modem router, or some kind of a vehicle computer device. There may be video, there may be real-time GPS positioning, something like RTK for precise precision automation. And then also looking at kind of a 3G, 4G, 5G connection to a LoRaWAN gateway, providing backhaul for the LoRaWAN gateway with a LoRaWAN RF front last mile connection to sensors. So that's also another good example. And I'm just going to touch on some of how that is managed in one of the next slides. So what we're looking here at is how are all these types of devices connected. So of course there could be different radio access networks, or fixed line, wireless, whatever the connection mechanism is to the edge device. But from a device management platform, you need to be able to connect to any of these types of devices. So one of those is, there might be a service provider with a particular IoT device, and there's only an API interface to that device. So you can only manage, configure, and collect data from that IoT device using an API. A good example would be things like Nest or a Google Home type devices in the home, where there's an API interface to the device. So bringing that on board in terms of device management is a no-brainer when that concept of the protocol adapter to the edge device is provided. And and this is probably the more typical, is having a specific sensor, a dedicated sensor, and the proliferation of narrowband IoT type sensors is happening at this time, and we're seeing all sorts of different NB-IoT sensors coming to market. And yeah, so many of these use different protocols, CoAP, HTTP, even MQTT in the non kind of power applications, and and we're seeing lightweight M2M being more deployed. And just mentioning that, so you'll see the vendor ecosystem when they're developing those NB-IoT based sensors. We have a supply from the NB-IoT module manufacturers, and the examples there are the U-Bloxes and the QuickTels and the Tellits and so forth, and Sequans and many more. So they provide a module, an NB-IoT module, and integrated in the module and they've already included a lightweight M2M client in the module. So it now makes it a lot easier for device manufacturers when they develop the product just to use the module off the shelf, and it's as simple as performing a couple of AT commands to the module to update sensor parameters, create new sensor parameters, and so forth. And so the device manufacturer now, without having to go and try and implement a management client like lightweight M2M, they just can use an off-the-shelf module and get all that capability from the module and connect. And so we have done interoperability with a number of those module manufacturers, and yeah, they work pretty well. So you'll see a lot more of those sensors coming on board using that lightweight M2M as one of the protocols. Connecting to gateways is another beast, mainly because many different manufacturers develop their gateways in different ways, different operating systems. And but we're seeing things like broadband gateways using, obviously the old TR-069, but the new TR-369 USP is becoming more prevalent now with some enhanced features. We'll go through that. And also MQTT. So, one of the use cases there with an IoT gateway is, for example, in smart home. So you will have a gateway connected with a Zigbee and Zigbee sensors. And then, for example, MQTT can be used in the gateway, and that MQTT client provides a bunch of topics, and the topics map to obviously the Zigbee sensors, being able to provision a new Zigbee sensor, collecting data or controlling that Zigbee sensor or Z-Wave sensor or Bluetooth sensor, and then providing the upstream MQTT topics back to the device management platform with those additional topics for the device management data tree that allow for more device management capabilities using MQTT. So it could be as simple as that. Then there's also the case of the Lauro Gateway, which in the past did not implement a device management standard, especially to the LoRaWAN edge devices. And the advent of Lightweight M2M version 1.1 a few months ago have adopted the concept of also managing LoRaWAN devices. So that has now become possible too. So just touching on kind of some of these clients and how the client fits into the edge device. So in this case, Lightweight M2M is used in constraint devices, so devices with very low footprint RAM, CPU, flash, and something that has to be in, typically could be power saving mode, but yeah, very, very low footprint type devices. So the Lightweight M2M protocol stack caters for a whole lot of options. And this is, by the way, Lightweight M2M version 1.1. And looking at this, so you could utilize the standard Lightweight M2M version 1.0 was Lightweight M2M, CoAP, DTLS, UDP. That's kind of the mainstream use in version 1.0. Version 1.1 now brings in the ability to do, for example, TLS and TCP. CIoT essentially refers to non-IP data delivery type interfaces like NB-IoT, Cat-M1, even LoRaWAN. So those allow for the connectivity to those edge devices, even in a non-IP connected world. So there is some interface technology for that, and we can perhaps cover that on one of the next slides. But also using out-of-band SMS, using direct UDP. But yeah, the strength here is the security, and so DTLS essentially secures the link and the channel between device and platform, and OSCORE provides an application level of security. So very good protocol to use for these types of IoT devices. So I think we all know kind of what MQTT is all about, so I'm not really going to go on to this too much, very light on information, except to say, of course, there's MQTT SN for sensor networks, utilizing UDP, so allowing for a little bit more resilience in connectivity in these mobile type networks. So that's an interesting one. And as I said, using this MQTT type approach with a gateway or even any IoT type edge device, and customizing that interface to whatever is connected, like sensors or could be RF connections, and bringing that back through MQTT topics back into a management system. So that's a well-used concept. We use that extensively too. The background here, obviously, the old world being TR069 in the in your home broadband devices. Most devices have them, but the evolution of that is TR369 USP. Brings in a lot more security, better privacy, some role-based access, better for more robust communications, so like these mobile networks. Then also, one of the good strengths of 369 USP is the ability to push container or microservices applications to gateways. So this opens up a very interesting area for specific IoT vertical applications. And yeah, if you're interested in that, let us know if you have any questions later on. So I was speaking about that MQTT client gateway integration, but essentially this is kind of what it looks like. So you'll have a MQTT client with the interface of the topics to a device management platform, so pushing sensor data up, but also allowing the control of the wired wireless type device endpoints. And so that app client agent, unfortunately, MQTT is not a device management standard. It's a publish subscribe protocol mechanism, and in this type of case, we're able to adapt the topic tree in the MQTT client to be able to fit into a device management platform environment. And why would you want to do that? Well, you want obviously the ability to be able to better manage MQTT-based devices. So for provisioning purposes, configuration purposes, for even being able to do a firmware over the air push down to an MQTT-based device. So really kind of formatting that MQTT-based edge device into a device management world. But I think you're aware IoT platforms all generally connect to MQTT devices, so it's quite a ubiquitous protocol to be used. Okay, friendly One-IoT. I was talking about all those challenges and all the problems, and so we have some of the answers for that, and that is our One-IoT Device Management Platform. So One-IoT is essentially unified. What is unified because we handle all protocols for all devices. And just a snapshot here is, lightweight M2M, MQTT, CoAP, 369 USP, OMA-DM, HTTP, and the others is being able to add in those custom protocols. So this, what we call our IoT engine and the smart layer is the southbound interface, so the interface to the edge device. And that smart layer allows us to easily bring in these new types of protocols. I'll talk a little bit about our kind of roadmap strategy there. But so we can connect to any of the devices on any of the access networks. So whether it's 3G, 4G, 5G, NB-IoT, Cat-M1. And as I showed earlier, lightweight M2M version 1.1 allows us now to provide management of LoRaWAN devices as well. But so covering the complete spectrum of all the access network type edge devices, whether they be IP-based or non-IP based devices, we are able to connect and manage those. So unified for us now means we connect to any type of device and protocol, and unified, we can now perform device management actions. So if we look at our admin console in the middle, the admin console as an administrator, and that is multi-tenanted. So any tenant or sub-customer within that admin console environment is able to manage their IoT devices in a similar way. So if they create a campaign, it doesn't matter about the protocol. It's the same procedure, same mechanism. It's unified in the way the device management interacts with the different types of IoT devices. Of course, there's various different portal applications that we offer on that, and another is a technician's portal. Technician's portal is kind of a single interface to the that device that's under consideration or under investigation. And the technician's purpose there is to help fault find an issue with a device. So we provide a whole bunch of tools and troubleshooting tools and all the configuration options all in one interface for the technician to be able to easily identify issues and rectify issues with a device that's been investigated. So we integrate into third-party application generators, and I'll show that a little bit later on. But yeah, there's a whole bunch of options there. We do have a provisioning portal as well, and that is significant in the IoT space because you may, as I said, want to pre-provision devices. So you may have some thousands of devices coming from a manufacturer. You may want to preload the security profiles for each of the devices after they bootstrap. Set up certain configuration options for them once they bootstrap and register, so that you as a provider or service provider can ensure a good network citizen for that particular device. So the provisioning portal can be used to pre-provision all of those types of configurations. And then there's event management and alarm options, and we also have a cybersecurity module for the platform as well. So the platform can be installed on essentially any environment. So it could be on your own premise server equipment. It could be on private or public cloud, or even a hybrid approach. And the reason for that is the development and architecture of our platform is not reliant on a cloud framework like you'll see with many IoT platform vendors. They're reliant on Azure or Amazon or Google or a particular cloud environment. We are not using those particular services from the cloud environment. However, we run out of a standalone server environment which can run on any virtualized machine. This is what we have deployed up to today. And moving, what we've already done is we've moved many of those components of ours, and we essentially have the kind of 3 layers to our system. We have our application layer, or what we call our portal layer, and that consists of all those GUI-based applications and APIs and so forth that we spoke of. And then we've got the engine layer, and we then have our what we call our database layer at the bottom. Now, these have been already in our R&D, have been migrated into containers for, we're using Kubernetes for the orchestration of these types of containers. So the technology stack that we're utilizing now is, you're looking at the Angular, and that running on a .NET Core, which is open platform, can run on iOS, Linux, or Windows. And those containers are then can be orchestrated into any target environment that supports the Kubernetes orchestration. And from a database, and on the engine layer, we utilize Java and JBoss, and it is very well suited to cross-platform use. And then on the database side, we can support a bunch of different database technologies. Let's call it our legacy, very large customers. We have been using the Oracle database with active high availability, and we're utilizing MySQL in a lot of the new larger deployments as well. So there's been a lot of advances in MySQL, and the ability to manage clustered MySQL server environments in disparate environments. So there's been a lot of advances there. So yeah, we support all that. There's a lot of design around load balancing and managing multi-site databases, and we're pretty good at that. So our device management platform is supported in those environments. So what is this device management platform in terms of services? Now, I don't have enough time to go through every single feature. I just want to touch on some of the main points. I mentioned multi-tenancy, so just allowing multiple customers and sub-customers of sub-customers to be loaded. We do, obviously, there's full FOTA, not just firmware over-the-air updates, but also could be configuration files, golden firmware, golden configuration images. It could be custom application files to the edge device. Yes, so whatever that particular device and protocol supports, we're able to push those application type files down to the edge device. Of course, there's lots of reporting built into the platform and interfaces to BI, all the logging and CDRs, the ability for bootstrapping, secure bootstrapping and secure registration. So that's all built in. One of the important points of our platform is we're seeing with operator service providers that it is the central device repository for the service providers. So what that means is any different protocol can be registered with a single platform, and with it supporting these open standards, the single device or device registry engine allows the service provider to be able to seamlessly manage, connect, integrate any of the devices to any of the IoT platforms upstream. We've got this, what we call a unified data model. I have a bit of a message here on my screen showing degraded audio. I hope that you can still hear me okay. If there are any issues in hearing me, please just let me know by message. Okay, so I was just talking about that device registry and its use in a multi-cloud environment at a service provider. We've got some nice integration options around integrating to cloud environments using things like Kafka, PubSub, AMQP, RabbitMQ, and Streams interfaces. So lots of integration options to various different clouds. There's a Microsoft Azure IoT Hub specific integration. We've worked with Microsoft in the US, and that's quite an exciting development that we've already finished. And then we have this block here called SCEF, and SCEF would be applicable to a carrier integrating their radio access network and providing an easy way to integrate to those access networks like 5G. So SCEF comes into the equation there because we integrate to SCEF for those non-IP type devices, and I'll touch on that on the next slides. So our device management platform, aside from all those device management features, it's one of its strengths is that collection of the data and pushing that up into cloud for analytics. So essentially, any of those device parameters on that is reported by the device can be put into what we call a monitoring mode, and that data will come in real time, or however it's configured. The profile is configured for transmitting, and that sensor data then is either warehoused or shifted by Kafka into a cloud analytics or big data environment. So it all depends on the target requirements from a service provider, but yeah, lots of different options there. Okay, so why our One-IoT? I think we spoke of these points, but it's streamlining this IoT service rollout. So being able to automate and bring in devices auto-discovered, and avoiding this need to do customization every time to bring in new types of devices. So one platform doing all the different protocols. It's a carrier-grade solution, so we managing if not tens of millions, some 100 millions of devices, and as I said, we're deploying a system now to connect up to more than 1 billion NB IoT type devices. So highly scalable, highly resilient, and integration with various app generators and SCEF and data analytics solutions and IoT cloud. So it's really that piece of the puzzle, but we have a lot of these integration options to these external environments. Managing the full life cycle of the IoT device. It's not just managing and configuring the format of the data coming from the device, but as I said, doing all that device management on the device itself. Managing constraint devices as well. A central device registry I spoke of, and we're cloud independent, so there's a lot of flexibility in what we have to offer there. Just covering some of the interoperability testing. So the device management protocols not often have what we call a proper certification. However, how we do this is in a test-fest environment, different platforms and different clients are all tested against each other to ensure compatibility between clients and platforms. But what we have developed in the past is a interoperability tester, and this is kind of a comprehensive tool for automating these tests. And so essentially our platform auto discovers the device's capabilities and displaying those, obviously the device's data model. And based on those data models, there are some predefined test protocols that are that can be executed, but those test protocols can actually be modified, or new test scripts can be created from scratch. So there's some comprehensive reports and interactive feedback on those test results. So having a look at if there's a pass-fail condition, what those particular conditions were or are. The capability to modify, create your own test scripts, as I mentioned. Testing firmware over the air support, so it's not actually doing the physical firmware push, but checking the protocol, in this case the firmware over the air protocol compliance with an edge device, and whether that supports the firmware over the air mechanism. Bootstrapping and registration process testing, so there's also built into that some of the security compliances that are needed for bootstrapping and registering. So each protocol has its own unique requirements around that. So that's essentially what is provided for in a testing protocol interoperability suite that may or may not help you. Okay, I was just talking about some of those integration options from our One-IoT. We've got about 9 minutes left, and I've just got a few more slides to handle quickly. So this picture is illustrating the One-IoT Device Management Platform integration into a carrier or service provider environment. The main point of this here is the integration to the SCEF block, and typically connecting to these kind of new 5G access networks, and being able to connect to NB-IoT CADM1 IP and non-IP based devices. So there's a T8 API we interface to the network operator SCEF platform, and we're able to then fully manage a non-IP device at the edge as well. Okay, so we did this Microsoft Azure IoT integration, and the important thing about this is that we have a full integration into IoT Hub, the Azure IoT Hub. So when a device registers on our platform, a device twin is created in the Azure IoT Hub, and that device twin is then available in the Azure IoT Cloud environment to develop applications, do machine learning, AI, analytics, whatever your flavor is in your IoT application. You're then operating on those device twins, and those device twins are dynamically created in the Azure IoT Hub based on the preset security profiles configurations in the provider's device management platform. So that's being our One-IoT platform, and it's not only lightweight M2M. It would be any of the protocols that we in our unified platform support. So even if it's MQTT or TL369 as an example, or OMA-DM or CoAP, those devices will dynamically be created in the Azure IoT Hub as well. And there's full direct method integration. There's properties requested and reported integration, and there's also direct messages as well from Azure IoT Hub to the device through our platform. So very excited about that, because we are seeing many enterprise customers starting to use the Azure cloud environment, not just for business applications, but actually for the Azure IoT cloud applications. So the generic kind of interface into cloud environments is via one of these either APIs, so we have this REST API, or using one of the cloud-based protocol schemes like, I mentioned Kafka earlier, RabbitMQ, PubSub, any of these different stream queues. So if you're developing a analytics application in Azure or Amazon, Google, Oracle, Alibaba, whatever, Ali Cloud, whatever your flavor is, it would be fairly similar between the different cloud platforms. And from the service providers device management platform, we will provide a standard integration interface into that cloud environment. Okay, just a quick snapshot, a few minutes left. What does a unified device management admin interface look like? So you can see under protocol types, there's all the different protocols of devices that are supported in one platform. So once that device is registered in the platform with its protocol, it has a standardized data model within the platform. So it doesn't matter what the protocol is when you start performing device management functions here. So for example, setting up CPE profile, which is a device profile, doing update groups, which is campaign management, so being able to create those firmware over there pushes and updates, or device configurations and so forth. So monitoring is one of those important points of what parameters from devices do you want to monitor? So like it be temperature, humidity, pressure, whatever the sensor parameters are from that edge device. You will use the monitoring to configure that once, and then those devices, dependent on your pre-selection of devices through the monitoring configuration, all those devices will then start sending that monitored data in real time to the platform. And from the platform, we can either push it into a real-time database or alternatively stream that off into your cloud data lake as you need. Then event monitoring is just really setting criteria around the parameters in the device for certain events. So the example would be perhaps a parameter goes out of bounds, and then to push out an event based on that. There's reporting, so a bunch of standard reports built in here, but also the platform can be integrated to your own BI environment. So we have a bunch of integration options there. File management is all about the firmware and application and configuration file management to push over there to the devices. So the file management essentially does manages the versions of the firmware images or applications or configs, the specific files for specific devices, and when you're logged in as a specific tenant, you will have access to your device and your configuration. So the file management in your tenanted area will be for your own use as a tenant. And yeah, so the settings there is really configuring the platform, and there's some specific protocol configurations there as well that can be done. So just looking at when we go into a device, a data model tree, we just expanded here a data model tree, and within any one of those objects within the data module, like I think we're on LTE status over here as one example, but there you can see the parameters for each one of those for that particular model. So download data rates, current and max min, etc., etc. So any of those parameters then are monitored and or are configurable of the parameters which are allowed to be configurable. But if under notification here it was on passive or active, then what that means is that parameter would be being pushed in real time to our platform for monitoring purposes. In other words, receiving pressure, temperature, those sorts of parameters, and that's all configurable in the system. Okay, so optional, we have an open source app enablement dashboard application, but we integrate to many different IoT app enablement systems. So essentially the difficult part there is integrating the tenancy, so the customers that are loaded in the platform, and which devices to which tenants, and mapping that back into a IoT platform. So this is what we've done. And this is just to give an example of an open source version of a app enablement system. So essentially it consists of the ability to set up rules for different conditions. Those customers are the tenants in the system, assets being non-monitored assets, buildings, farms, etc., etc. devices being the monitored stuff, so that'll be all the devices you see in our device management platform will be accessible in such an IoT app enablement system, so you can access the data from those devices. Okay, we got 1 minute left, so I'm running a bit short, but the app enablement system includes like a Node-RED rules engine, the ability to load up customers and devices, so those devices come out the device management platform and the customers do. The widgets, like lots of standard widgets off the shelf, and you can customize and create and develop your own. There's different dashboard applications as an example. And just the very last slide is we have a bunch of different clients. So it's not just the device management platform, but if you're developing a product and you need a client, we have a bunch of software developer kit clients available for use. And with that, I think we've come to the very last end minute of the webinar, and I will just leave you with why friendly. So thank you very, very much for your time. Much appreciated. If there are any questions, let's see. I've run out of time. What I will do is just get back to any of the questions that have been posed. And yeah, if you have any further interest, please reach out to our team and we will surely be able to help you. Okay, thank you very much, guys. Have a good day.